In 2022, it's been the newly launched James Webb Space Telescope stealing most of the headlines. Its predecessor still has a lot to offer science. The Hubble Space Telescope has been busily scanning the skies since it was launched way back in 1990. And it's thanks to Hubble's incredible longevity that this latest discovery was possible. In the year 2007, Hubble spotted and photographed a particular object in a particular part of the universe, the proto-exoplanet now known as AB Aurigae b. Then, in the year 2021, the same planet was photographed again to monitor its progress, and details were released in 2022 with an in-depth multi-authored study also published in the journal Nature Astronomy. The images themselves appear little more than an orange-red blur to anyone not attuned to exactly what they show, but astronomers have gotten quite excited by them, mostly because they appear to show a planet that must have formed in a quite unusual way. The AB Aurigae system is centered around a young star, some 530 light-years away from us. It's not likely, then, to ever directly affect our particular corner of space. And yet, we can learn just a little bit more about the solar system, our galaxy, and the universe in general just by looking at it. The visuals produced by Hubble, in conjunction with the Subaru telescope located in Hawaii and operated by the National Astronomical Observatory of Japan, have provided insight into a little-known planetary behavior. The planet AB Aurigae b is widely described as being Jupiter-like in terms of composition. It's also around 9 times the mass of Jupiter, and it orbits some 93 astronomical units away from its star, which is a seriously long way. It's more than 8.5 billion miles. For comparison, the Jupiter that we know orbits just a little over 5 astronomical units away from its star. Even Neptune, the furthest planet from the Sun, is only a third of AB Aurigae b's distance at around 30 AU. The reason why this is so strange is because the leading model of planet formation doesn't really allow for planets to form at such an incredible distance. And yet, we know that AB Aurigae b is there, having been birthed out of a protoplanetary disk of debris like all planets are. For a long while, the leading theory on how Jupiter-like worlds like this form, huge enigmatic gas giants, has been something known as core accretion. This is when a planet's core is gradually forced into being, as small chunks of debris in the protoplanetary disk are brought together via collisions and mergers. Over time, a stable core is made, which attracts more and more material until, voila, you have a planet. But that can't be what's happening here, because AB Aurigae b is simply too far away. Its orbit is too long and too wide, to the point that core accretion should just take far too much time, even in cosmological terms. Or it could, in fact, be impossible. So, what's actually happening? We have clear evidence that a planet exists, but based on the most prominent theory, we don't immediately know how it exists. There is, however, another approach. As well as core accretion, scientists also refer to the disk instability model. And while it's not quite as popular an explanation as to how planets form in general, it could be what happened to bring AB Aurigae b into life. Disk instability is in many ways the reverse of core accretion. While core accretion relies on space debris drawing itself together to form something bigger than its smaller parts, disk instability relies on would-be core objects breaking free of the protoplanetary disk. Those at Hubble describe it as a top-down model, where a massive disk cools, and gravity causes the disk to rapidly break up into one or more planet mass fragments. In particular, it's a candidate for what could be happening whenever a planet forms far away from its star. Under those conditions, the protoplanetary disk is massive, cutting, as it does, a hugely long-distance path around its gravitational anchor. And if we were to somehow teleport ourselves to the AB Aurigae system right now to view it from the outside, then a setup like this is what we'd find. Perhaps some of the surprise around this planet, then, AB Aurigae b, is a little unexpected. After all, it's not as though it's a world that has truly appeared out of nowhere. Science is fairly certain of a way in which it could have come into being. It's just that it's a totally different way compared to the gas giants in our own star system. But that, of course, makes it extremely interesting. It may continue to be described as Jupiter-like forevermore, but in terms of its origin, its story is quite unlike what Jupiter experienced. But what else can be derived from this observation? In some ways, this is just the latest on an ever-lengthening list of new planets found. But could it also have repercussions for us here in the solar system? What if, for example, disk instability had happened in our corner of space too? Would that mean that a similarly distant but unknown planet could be orbiting the Sun right now, way beyond Neptune or even Pluto? There are, of course, various theories pertaining to a Planet 9, a proposed hidden world that's said to cruise through the very outer edges of the solar system, waiting for us to one day find it. And really, if there were a planet so far from the Sun that we still haven't actually discovered it, then perhaps it would have formed via disk instability. However, there's little by the way of solid evidence that Planet 9 does exist. There are many compelling possibilities, many of which we've investigated in a previous video, but so far, there's been no great moment of discovery or revelation. There's been no great arrival of another solar system world. As for the Hubble telescope, what will become of it now that the James Webb is up and operational? For so long, it's been an astronomical icon and a symbol of humanity's technological drive. But is it on its way out? Will it still be around in another 14 years or so, for example, to take another picture of AB Aurigae b and update us on its progress? Sadly, the answer is probably not. While Hubble doesn't have a specific date at which it will end its service, predictions are that it will finish sometime in the late 2020s or 2030s. When it does so, there are a couple of options, including allowing it to fall back to Earth, and if it does drop from the sky, then it'll truly be the end of an era. Arguably more so than any other mission or machine, Hubble has opened up the universe to us. It's helped solve countless mysteries and has infinitely added to our collective knowledge. And really, the charting of AB Aurigae b, an alien world that's hundreds of light years away from us, is a prime example of exactly what Hubble does best. So, what's your verdict on AB Aurigae b? Should its existence mean that we start viewing all star systems with an entirely new perspective? Has the hunt for exoplanets just been blown wide open? Might the disk instability model have more influence on the universe than it's currently given credit for? In some ways, this does rank as a particularly significant study, and AB Aurigae b can be considered something of a maverick world alongside most of the rest of the other planets we know about. But also, science does at least have an answer as to how it came to be there. Core accretion remains the prevailing method for planet formation we've theorized so far, but disk instability offers another option. So, while it might not be exactly fair to say that it's broken the rules of the universe, that's why this planet is at least a little unconventional. When it comes to the universe, it's still all a matter of balance, but AB Aurigae b is proof that there's more than one way